This is our next chapter, that is communication systems. Yes. So what is mean by communication? Communication refers to the transfer of information or message from one point to another in an understandable form. Okay, you know this means what? Transfer of any information in user understandable language, we can say. That is what communication is. Next, you see how is the block diagram of communication system. So you can see here. This is information source, then this is message signal, then this is transmitter, transmitted signal, then channel, then here it is noise, may add received signal, then receiver, and then this message signal, and then user of information. For example, when you are talking via telephone, that is landline, there should be some signal, that is message signal, which is transmitting through the wire. Then this everything is getting converted, and then again at receiver end, the signal will get converted into user understandable language. Understood? Yes. Next you see which are the basic modes of communication. There are two basic modes of communication: point to point mode and broadcast mode. Point to point mode of communication takes place between a single transmitter and single receiver. जैसे कि telephone है, only one signal or one single transmitter and one single receiver is there. That is what point to point mode. One person that side, one person this side. Yes, no. Whereas broadcast mode means there are a large number of receivers corresponding to a single transmitter, radio and television broadcasting. One time they are broadcasting and then all users are listening. Yes, no. Whereas telephone is not like that. It is point to point mode, and broadcast mode means radio or television programs. Understood? Clear? Yes. Next one. Now, what is a transducer? What is a transducer? Transducer means what? Any device which converts one form of energy into another. For example, microphone, loudspeaker, LED, photodiode, electrical energy to light energy, electrical to sound, whatever, one energy to another. If it is converting, then that device is called transducer. Next is what is signal? Which are the two different types of signal? Information converted into electrical form and suitable for transmission is called signal. Whatever we are speaking, that signal, if we are converting into electrical signal, then it is easy to transfer. Yes, no. Now signals are of two types. One is analog signals. They are the continuous variation of voltage or current. Sound and picture signals in TV are analog signals. The second one is digital signals, and these are which can take only discrete stepwise values. Just binary form, we can say BCD or ASCII. These are the what we can say types of digital signal. Next is what is mean by noise in communication. Other than signal, whatever it is there, that is what noise only. Yes, no. What is meant by noise in communication? For example, you are speaking on phone, and if small kid is crying nearby, and the another person who is receiving that signal, he is getting little sound of that crying boy or crying child, that is nothing but what? Noise only, other than signal. Yes, understood? Okay. Now see the question. What was the question? As already I have explained, what is noise? So unwanted signals that tend to disturb the transmission and processing of message signals are called noise. Yes, no. Already I have explained with one example also. Next is what is transmitter? Transmitter means what, Ray? The one who transmits. Yes, no. The one who is transmitting means who transmits. So transmitter is an electronic device which makes the signal suitable for transmission through a channel and subsequent reception. That is called transmitter. Next is channel. What is channel? Channel is the physical medium that connects the transmitter and receiver. जो ट्रांसमीटर को और रिसीवर को कनेक्ट करता है वो क्या है? चैनल. A channel may be in the form of wires or cables or it may be wireless. तो ये वायर के साथ भी हो सकता है, केबल्स के साथ, or else without also. Means wireless. Yes, no. What is receiver? What is receiver? It is the device which separates the message signal from the received signal. Yes, no. That is called receiver. What is meant by attenuation? The loss of strength of signal while propagating through a medium is known as attenuation. We are saying no, range is not there, range is not there, but actually that is what attenuation means. What? The loss of strength of signal. Yes, no. What is meant by amplification of signal? Amplification means what? A process of increasing the amplitude of the signal using an electronic circuit called the amplifier, and amplification is necessary to compensate for the attenuation. One simple example I will tell, which is just related. We can say we know mic and loudspeaker. So what happens there? It amplifies. Yes, no. It amplifies the signal. Yes, no. Clear? Loudspeaker and microphone. Yes, no. You are speaking with very low voice, but it will amplify. Yes, no. And amplification is necessary to compensate for the attenuation of the signal in communication system. Okay. Next is defined range. It is the largest distance between a transmitter and destination up to which signal is received with sufficient strength. Okay. Range is not there. Range is not there means you are not in range. Yes, no. Clear? So it is the largest distance between a transmitter and destination up to which signal is received with sufficient strength. That is what range is. Next is defined modulation. Modulation is the process of superimposing low frequency signal on high frequency carrier wave. This modulation, why it is necessary? Basically, modulation means change. Modulation means change. If I am speaking, this voice should go to the many people, or it should reach to many people via channel, we can say. Then we should modulate that whatever the wave is with high frequency carrier wave, and that is nothing but modulation. Then what is demodulation? Demodulation is what? The process of separating signal, hai na? The process of separating low frequency signal from modulated wave is known as demodulation or detection. Yes. Next, what is repeater? A repeater is a combination of a receiver and a transmitter. A repeater is a combination of receiver and transmitter. A repeater picks up the signal from the transmitter, amplifies it, and retransmits it to the receiver, sometimes with a change in carrier frequency. And example, dekho, a communication satellite is a repeater station in space. Mobile towers are example of repeaters. जो मोबाइल टावर्स है वो रिपीटर्स ही है. समझ में आया? घरों के ऊपर रहते हैं वो क्या है? रिपीटर्स है. वो क्या करते हैं? Picks up the signal from the transmitter, amplifies it, and retransmits it to the receiver, sometimes with a change in carrier frequency. Okay, that's why when tower we are getting is near, then we will get good strength of signal. Yes, no. Define bandwidth. Bandwidth refers to the frequency range over which an equipment operates. Means what? Minimum to maximum. What is the frequency range? That is what bandwidth. Understand? Explain what is meant by bandwidth of signals. For speech signals, frequency range is 300 to 3100 Hz. Therefore, speech signal requires a bandwidth of 3100 Hz minus 300, that is 2800 Hz. This speech signal means whatever we are speaking, its minimum frequency is 300, maximum frequency is 3100 Hz. And that's why bandwidth we require is what? This minus this. This minus this. How much it is? 2800 Hz. To transmit music, a bandwidth of 20 kHz is required. For transmission of picture video signal, a bandwidth of 4.2 MHz is required. And a TV signal contains both voice and pictures, so it requires 6 MHz bandwidth. Understood? So देखो, speech signal means only voice. It requires bandwidth of 2800 Hz. Music, this is 20 kHz. And TV signal or video pictures only, it requires 4.2 MHz frequency. And TV signal, voice and picture, 6 MHz. Okay. Next one is explain what is meant by bandwidth of transmission medium. Coaxial cable offers a bandwidth of 750 MHz, and communication through free space using radio waves takes place. Okay. So let's move ahead. So optical communication using fibers is performed in the frequency range of 1 terahertz to 1000 terahertz. An optical fiber can offer a bandwidth of excess of 100 gigahertz. 1 terahertz is equal to 10 power 12 hertz. Give the frequency bands used in a various important wireless communication system. अब ये जो frequency bands है एक बार देखो, इसके ऊपर आपको क्वेश्चन आ सकता है. See here, standard AM broadcast. AM मतलब विविध भारती, इसका जो रेंज रहता है वो 540 to 600 किलोहर्ट्ज. FM का देखो आप, सारे चैनल आपको 88 to 108 मेगाहर्ट्ज पे मिलेंगे, जैसे कि 93.5 है, 95 है, जो भी है 94.3, 92.7, all are in between 88 and 108. If you will set the frequency more than 108 or less than 88, FM will be not there, है ना. Television 54 to 72 and 76 to 88. This is very high frequencies. This is for TV. Then this is UHF 174 to 216, 420 to 890. This is for TV. And cellular mobile radio 896 to 901. Mobile to base station, and base station to mobile it is 840 to 935 megahertz. Satellite communication 5.965 to 6.425 gigahertz. This is uplink, and 3.7 to 4.2 gigahertz downlink, means from up down to up and up to down. Okay, got it? Next one, which are the three different modes of transmission of electromagnetic waves? Ground wave propagation, skyway propagation, space wave propagation. Ground wave propagation, the waves which are along the ground, or communication takes place via waves which are transmitting along the ground. Skyway propagation through ionosphere we can say, space wave propagation through satellite we can say. So explain ground wave propagation first. The AM radio waves which propagate from one point to another following the surface of Earth are nothing but what? Ground wave propagation only. Yes, called ground waves or surface waves. The ground wave propagation is used only at low frequencies. इधर देखो 540 kilohertz to 1500 kilohertz is the frequency for ground wave. Next is the AM band which can be sent as ground waves is called medium waves. Okay, और ये जो ground waves है इसका जो wavelength रहता है वो greater than 200 मीटर रहता है. Okay. Next one, what are the properties of ground waves? Ground waves have longer wavelength, so they have high diffraction and low attenuation. इनको क्या होता है, high diffraction रहता है और low attenuation रहता है. Ground wave propagation does not take place to a very large distance. Why? In ground wave propagation, the intensity of the signal falls with distance due to absorption from the ground. तो जो signal का जो strength होता है वो थोड़ा सा कम हो जाता है. So that's why ground waves are not used for long range propagation. Clear? Now next. High frequency waves cannot be sent as ground waves. Why? Because of low diffraction and high attenuation, high frequency waves cannot be sent as ground waves. Explain skyway propagation. See here, how is the skyway propagation? Already I told you skyway propagation means via ionosphere. The propagation of radio wave or AM signals from one point to another via reflection from the ionosphere is known as skyway propagation. It is mainly used for long distance radio communication. You see here, this is a wave, it is going and getting reflected by ionosphere and it is coming back also. Understand? So in skyway propagation, a frequency range of 2 megahertz to 30 megahertz is used. And this region in AM band is called short wave band. Short wave band. If you will purchase a radio, in that you may have this. Okay. Next one. Why it is getting reflected? That is the reason. The refractive index of ionosphere is less than that of free space. So the transmitted waves suffer total internal reflection. Already you know total internal reflection in ray optics at the ionosphere and are reflected back. There is a maximum value for frequency above which no total internal reflection takes place. This frequency is called critical frequency. Critical frequency means what? Maximum frequency above which no total internal reflection takes place. And this critical frequency is equal to 9 into n max whole power 1 by 2 or root n max, we can say. N max is the maximum electron density of the ionosphere, that is electrons present per unit volume. So if someone is asking you critical frequency is what, and you find out, then 9 root n you have to use formula, where this n max is what? Electron density, that is electrons present per unit volume. Got it? Next question. What is mean by skip distance? What is mean by skip distance in ionospheric communication? It is the shortest distance from the transmitter at which a skywave of fixed frequency will be returned to Earth. ये skip distance क्या है देखो? It is the shortest distance from the transmitter at which skywave of fixed frequency will be returned to Earth. तो जो भी फिक्स फ्रीक्वेंसी है वो वापस अर्थ पे आना है, वो है आपका स्किप डिस्टेंस. यस. नेक्स्ट वन. एक्सप्लेन स्पेस वेव कम्युनिकेशन. सी हियर. Skywave finished. Skywave communication is via ionosphere. Now this is what? Space wave communication. In space wave communication, the high frequency wave travels in a straight line directly from the transmitter to the receiver. Next, waves of frequency greater than 30 megahertz are sent as a space waves. So first of all, more than 30 megahertz, whatever the waves are there, we are going to send them to the space. The frequency modulated TV signals are transmitted in space wave mode. For the transmission of signals to the faraway stations, either repeating stations or satellites are used. तो स्पेस वेव कम्युनिकेशन के लिए क्या यूज होता है? सैटेलाइट. क्यों? दे आर बिहेविंग एज अ रिपीटर्स. नेक्स्ट, व्हाट इज मीन बाय LOS? व्हाट इज मीन बाय LOS communication? Space wave depends on line of sight condition. Actually, LOS means line of sight. They are limited in their propagation by the curvature of Earth. So space wave communication is called line of sight communication. ये जो space wave communication है that are depend on curvature of earth, yes no, limited to their particular part, and that's why they are calling it as a line of sight communication. Next, derive the relation between the range and height of the antenna in space wave mode. You see here now, this is what antenna, this is radiated wave, and this is r radius, and this is what distance. So let's see how to calculate this. Diagram you see once. This is antenna height h, this is d, and this is r, okay, and this is a point, this is d point. Now you see from the right angle triangle ABCD, CD square is equal to h square plus d square, and this CD square is nothing but r plus h whole square, which is equal to r square plus CD square. And just expand this and cancel it, whatever the same is there, and you are getting d square is equal to 2rh. Yes, no, this h square will get cancelled with this r square will get cancelled with this, and then you are getting d square is equal to 2rh, which is equal to d is equal to under root 2rh. Okay, next one. What is the maximum line of sight with distance between two antennas? You see here, this is two antennas. You can see here, this is transmitter, this is receiver, and HT and HR you can see. Can you see here? HT and HR. HT and HR is nothing but height of transmitting antenna and height of receiving antenna. So already you have the formula under root 2RH. So under root 2RHT plus under root 2RHR. That is what your maximum line of sight. What you have to do, this distance you have to find by adding these two. Okay, next one. What is the expression for the area covered by the signal in terms of the height of the antenna? Area covered is equal to pi d square, and that is equal to pi into this d square means 2rh. So pi to rh is what? Your expression for area covered. Next one, what is modulation? Already we have seen the process of superimposing low frequency signal on high frequency carrier wave is what? Modulation. What is the necessity of modulation? Why it is necessary? This question also may come for what we can say in IP 2 marks. Okay, so keep it in mind. See here, the modulation is necessary because of the following three reasons. What are those reasons? To reduce the height of antenna. Number one reason, to reduce the height of the transmitting antenna. For the effective transmission of a wave, the antenna should have the minimum height of 1/4 of the wavelength of the signal. Means what? Here, height of antenna should be 1/4 of wavelength of the signal. Okay, but audio signals have very large wavelength, so antennas of several kilometers height are not required for the transmission. Suppose now lambda is equal to, let us take it as a 200 or something, 200 meter. I am taking 200 meter, or suppose 500, or let us take 2000 meter. What we will do, we will take lambda as a 2000 meter. Then lambda is equal to how much? 2000 meter. So height of antenna lambda by 4 is equal to how much here? 2000 by 4. So this is equal to 500 meter. Yes, no? 500 meter means nearly 50-story building. Yes, no? Understand? So likewise, more than that. Okay, this is just one small example for understanding. So if like that, what you can say, we have to construct, we require very large antenna. Yes, no? If modulation is not, we did not modulate. So if we modulate the baseband signal with a high frequency electromagnetic wave, the wavelength becomes small. Therefore, antennas of only several meters height are required. Got it? Next one, to increase the effective power radiated by an antenna, So effective power radiated by antenna is directly proportional to n by lambda whole square, length of antenna, and lambda is what? Wavelength. So to increase the effective power radiated by the antenna, this is also another reason to modulate the wave. The power radiated for longer wavelength baseline signals will be small, but if you modulate the signal with high frequency electromagnetic wave, the effective power radiated will be high. And one more reason, what is that? To avoid mixing up of signals from different transmitters. If we will modulate wave, no, it will not, means other signals will not get mixed with that. That is what one more benefit of modulation. Okay, clear? Now see, what are the different types of modulations? So first one is continuous wave modulation and pulse wave modulation. So in continuous wave modulation, how many types we are having? Continuous wave modulation have three types: AM, FM, PM. AM means amplitude modulation, FM means frequency modulation, PM means phase modulation. Okay. And this pulse wave, the second one, pulse wave modulation is again divided into pulse amplitude modulation and pulse width modulation, that is PWM and PAM. So basically you have these two types main, and then out of that two, again you have first one have three parts and second one have three, that is pulse position modulation also, PPM and PDM, PAM. अब ये सब क्या है देखो, this is pulse rise, pulse duration, pulse fall, and pulse amplitude. So this we will see ahead in detail. Next, define amplitude modulation. In amplitude modulation, the amplitude of the carrier wave is varied in accordance with the signal. Means what we are doing in amplitude modulation, we are varying the amplitude. Okay. Next one, you can see here modulating signal, carrier wave, and then amplitude modulated signal. You see here this carrier wave and this is signal we are fixing with this, and this is what your amplitude modulated wave. Next one, define frequency modulation. And in frequency modulation, what we will do, we will change the frequency of the signal. You can see here, this is modulating signal, carrier wave, and frequency modulated signal. You see here the frequency is changed. Understand? Here the amplitude is same, but frequency changed. That's why it is frequency modulated signal. But whereas in above case, amplitude was changed, you can see here. You see here this amplitude is changing. Can you see the displacement is changing from mean position? That's why it is amplitude modulated wave. Whereas here you see down, here the frequency is changed. Number of waves per unit time is changed. Here it is more waves, here it is less wave, more waves, less wave. That's why it is frequency modulated signal or wave, we can say. Got it? Now see, obtain the expression for an amplitude modulated wave. Give expressions for side band frequencies. Let this frequency or displacement is AC sin omega CT represents carrier wave. M of t, AM sin omega mt represent the modulating signal, and then from the superposition, just we are going to add, and this one, that is mu, that is AM by AC, is called the modulation index. This you keep it in mind. Next one, in practice, mu is kept less than or equal to 1 to avoid distortion. Okay, and then this one, CMT AC sin omega CT plus this, you can just add that. From the above equation, it is clear that the amplitude modulated wave contain three frequencies: omega C minus omega m, and omega C plus omega m. Okay, so sideband frequencies are what? Omega C minus omega m and omega C plus omega m are lower and upper sideband frequencies. This is lower sideband frequency, this is upper sideband frequency. Okay. Next one, they are asking you draw the block diagram of an amplitude modulator. Amplitude modulator का draw diagram आपको पूछ रहे हैं. So see here, like this modulated wave, square power band. Hello.